Getting into space is a massive challenge, but the more we do it, the harder it becomes. Every rocket launch leaves behind empty fuel tanks and broken satellite parts, wrapping Earth in a chaotic, multiplying web of trash. This debris orbits at speeds up to 30,000 kilometers per hour. At that velocity, a piece of metal, the size of a pea, hits with the energy of a plasma gun, vaporizing on impact and spraying thousands of new, sharp fragments into the void. As these collisions multiply, they create a slow-motion domino effect. Within just a few decades, this cloud of hypervelocity shrapnel could form a barrier, dense enough to permanently trap us on our home planet. Launching metal cylinders filled with explosive chemical fuel is becoming a localized trap. It is a primitive method that is actively sealing our exit from the solar system. Even if we clear our orbit, we face a much larger problem. The Milky Way spans roughly 100,000 light-years, a distance that dwarfs our current understanding of travel. Probes like Pioneer and Voyager represent our best attempts to cross this void. We attached golden plaques to them, etched with maps of our solar system and drawings of human anatomy, in a bid to communicate across the galaxy. These probes travel at tens of thousands of miles per hour. Yet on a map of the galaxy, they have barely moved a fraction of a single pixel in 50 years. Moving mass through space using consumable fuel is a process measured in millions of years. This reliance on classical propulsion ensures we will never bridge the gap between stars. To move faster using the rules of classical physics, we have to think on a scale that ignores individual ships entirely. We have to move whole star systems. This is a Kaplan thruster. It uses electromagnetic fields to siphon hydrogen and helium from the sun, fueling thermonuclear fusion to shoot a fast jet of particles backward. A second design uses a giant parabolic mirror to catch solar radiation, slowly pushing the sun forward. These engines could turn the solar system into a spaceship, allowing future civilizations to dodge galactic hazards or visit other stars over millions of years. But even these engines hit a wall. They are still limited by the need to push mass through space, a strategy that remains too slow for the scale of our galaxy. Finding a faster way requires a different understanding of the universe, rooted in the theories of Albert Einstein. Einstein showed that as we approach the speed of light, time slows down and the very distances between stars begin to distort. This is because space is not a static vacuum. It is a flexible, elastic fabric. Massive objects like stars actively stretch and warp this fabric. It is a physical thing that can be manipulated. Mastering the stars requires us to focus on this geometry. To cross the galaxy, we must learn to move space-time itself. A traversable wormhole is a hack for the laws of physics. It folds the universe to create a short bridge between two distant points. But the problem is gravity. The universe's weight wants to pinch the tunnel shut, crushing anything inside to keep the bridge open. We need to harvest exotic matter from the quantum fluctuations of empty space. This matter has negative mass. Its repulsive, gravitational effect pushes the walls of space-time out, providing the pressure needed to stabilize the wormhole. This approach sidesteps the light-speed barrier entirely. It turns the infinite distance of the galaxy into a series of local doors. A ship silently enters a distortion near Earth and emerges instantly in a new star field. There is no travel time, there is no distance. This capability changes our relationship with the universe. We move from pushing objects through a vacuum to utilizing the geometry of space-time. The immense distances and physical hazards of our orbit become engineering variables. Their ability to limit us scales with our understanding of physical laws. Our reach will not be determined by the light years between stars, but by the limits of our own scientific curiosity.